All right, jump back to your notes packet then, the significance test, the basics. And we filled in the front part, but we're going to come back to, so here's this, what's all kind of written out here, sort of the big idea behind significance tests, okay? It says, suppose a basketball player, in this case Mrs. Robert, but actually this is a different situation, but claimed to be an 80% free throw shooter. To test the claim, we have him, so this was not Mrs. Robert, attempt 50 free throws, and this person makes 30 out of 50, or 32 out of 50. His sample proportion then would be p hat equals 32 out of 50, which is 64%, or 0.64. Well, what can we conclude about this? Well, just like it is, we could just say, oh, well, their sample was less than their claim. But if we want to actually conduct a test, what we want to do, there's basically two approaches. We can simulate what should happen and base it off of a simulation. Or we can take the theoretical approach of what would a sampling distribution look like if we took every single possible sample of size 50. Like, would I possibly miss all 50? Maybe. It's possible, but I would have to base it on what's the standard deviation that's likely if I started to take samples. Okay, what we did on this page, instead of going the theoretical approach, we take a simulated approach. So right here it says we use software to simulate 400 sets of 50 shots, assuming the player really is an 80% free throw shooter. So this is the key. What we do is we start with an assumption. And that's going to be our null hypothesis. Eventually, we're going to write that. So I'm going to have you jot it down right now just for this sake. H naught, H sub 0, equals 0.80. That's our null hypothesis. It's the assumption that's being claimed. And we're trying to test against that in favor of something else. So our alternative hypothesis can be stated lots of different ways. You'll see when we get into it. But in this case, it doesn't say that we have any kind of other assumption. This is just the person says they're an 80% free throw shooter. Maybe we want to know if they're less than that. Because that's what you guys all thought, right? When I told you I was 80%, be honest. You're like, yeah, she's probably not going to make 80%. I didn't think I was going to make 80%. And I didn't. I was less. So what we can do is state what's called our alternative hypothesis, less than or equal to 0.8. Actually, we'll just say less than. We already have the equals 0.8 up there. So less than 0.8. So I stated that wrong, sorry. Less than. And so what we do is we take either a simulation, or later on we'll talk about theoretical, okay? And we base everything on the 80%. So what should we see in the long run if we take many, many, many samples? Well, in this case, this is 400 samples of size 50. Do we see it centered at 0.8? We should. When we learned about Chapter 7, sampling distributions, the center of our sampling distribution should be at the center of our, hypothesized in this case, but in the center of our population, 0.8. But then from there, notice there's the spread is like not, I mean, you go out about a little further than 10%, 0.1 and 0.1 on the other end, and you pretty much cover all the data. So our standard deviation is probably quite small. I didn't calculate it for this case. Okay? But what you can see in the simulation is that if we talk about comparing with what this guy got, 0.64, you can see we've circled, here's the 0.64, and there's two other ones below it. So only 3 times out of the 50, so 3 out of 50. Oh, sorry, 400. Man, thank you, Jarrett. 3 out of 400. So only 0.0075% of, not percent, so 0.75% of the time did we get a value as low as 0.64. But that's what actually happened when he shot. And so what we're saying is this probability is so low that we have evidence against the claim of 0.8. Remember when we first started today, I told you we're going to get a probability number. And a small probability means we have actually evidence against the claim. And if a large probability means we just don't, it could have happened, right? And so that's the idea. But there's really two choices here. Once we get this 0.75%, we either say the player's claim is correct and just had very, very bad luck that day. He really is an 80% free throw shooter, just happened to shoot very poorly. That's still possible. But the more plausible idea is this one. The population proportion is actually less than 0.8. Does that make sense? So we're going to use some terminology now that this one is what's called possible, but the number 2 is actually the more plausible. And that's because it was only like 0.75% chance that we get this first one to happen. And so it's possible, right? But not very likely. And so this one is the plausible answer. And there's a basic idea typed at the bottom that I would just encourage you to reread every time that you're conducting a hypothesis test. And it's an outcome that would rarely happen if a claim was true, is actually good evidence that the claim is not true. So this guy made a claim of 80%, but then he went and shot 64%. That outcome is rare that it happened. It only should happen about 0.75% of the time. And so that means, shouldn't have happened. Therefore, maybe this 0.8 isn't true. Are you guys tracking with me on the logic? Okay. So let's get into some of the nitty-gritty stuff. On the back, what I'm going to first do is just state what we just said in general, as far as the possible versus plausible. What are our possible outcomes? So any significance test, you have two possible outcomes. The first outcome is that the hypothesis could be correct. But the sample statistic differs by random chance. Still recording, yes. Our other possible outcome, possible explanation, I should say, is that sample statistic differs because the hypothesis is actually incorrect. And those are our two explanations, and it kind of depends when we run the test as to which decision we go with. Now that's the way the book words it. I do want to be cautious with you about number 1. We usually won't ever say that the hypothesis is correct. So I don't know why the book words it that way right here. If you want to think about it that way, it's okay. But what we say is that we don't have evidence against it. We're not proving that it's true, though. We're just saying we don't have enough evidence to say it's not correct. Okay, on page 531 of your textbook, it talks about how to state hypothesis, but I'm going to write down what's mostly important here, so I don't think we need to look at the book. The claim tested by a statistical test is called the null hypothesis. I mentioned that on the previous page. And we call it H sub 0, but it's H naught is how you say that. In physics, you use like T naught, right, to represent time 0 at and V naught, initial velocity. Naught. Naught. Fancy. I don't actually know how to spell it. The test is designed to assess the strength of evidence against the null hypothesis. Often, the null hypothesis is a statement of no difference. What that means is if there's a claim made, that's what our null hypothesis is. Okay? And then the claim about the population that we were trying to find evidence for That is kind of worded weird. Cross this out. Just cross this part. Say, we are trying to find evidence for the alternative hypothesis. I don't want to call it the claim because that's going to confuse you. The claim is generally your null hypothesis, and your alternative is represented with H sub A, not A sub 2, or H sub 2. In our free throw example, I wrote it on the front page, but just so you have something to look at, we use H naught with colon and then P equals 0.80 versus H alternative, P is less than 0.80. That was for the free throw situation. Now, I might make a note that in Mrs. Roberts' case, some of you might have not had any idea if I was going to be less than 80% or more. And so there's times where we'll run what's called a two-sided test that might look like this. The null is still 0.8, but your alternative is just that P is not 0.80. And you'll see why in a minute why that's called a two-sided test. But maybe you would think that because you don't have a reason to think I'm less other than that I'm old, right? And it's hard to think about like an older person being able to shoot an 80% free throw. Or maybe it's just 80% is pretty good and it's hard to say that. Okay. In any significance test, the null hypothesis has the form H naught colon parameter equals some value. And the alternative will look like this. Parameter either less than a value, greater than a value, or not equal to a value. Or kind of, those are basically our options when we write hypotheses. Okay, and then the alternative hypothesis is called one-sided. If it states that a parameter is larger than the null hypothesis value, or if it states that the parameter is smaller than the null value. But it's going to be two-sided if it states that the parameter is just different. Or you could say not equal to. And in that case, we're just looking at, do we have evidence that we're either smaller or larger? And usually we'll take on one side, but we don't know ahead of time what to expect, so we run what's called a two-sided test. Okay, a hypothesis always refers to a population parameter, not to a sample statistic. So be sure to state H naught and H alternative in terms of parameters. It is also never correct to write a hypothesis about a sample statistic, such as p hat equals or x bar equals. So your hypotheses will always have a parameter, so mu for mean, or p for proportion, not p hat, not x bar. Okay, go to page 531 of your textbook, everybody.